Hi there, and thank you for clicking on our practice set for radical equations part one. These equations are going to focus on equations that involve one squaring and do not generate extraneous solutions. So if you're looking for a more advanced practice set, you might want to check out radical equations part two. As always, like and subscribe if you find this video helpful. Drop a comment or a question below and check out the many other videos and playlists that are on the channel. Without further ado, pause the video to work these problems on your own and then come back to check your work. As a heads up, numbers 3 and 10, if you look at the little asterisk there, they are going to require use of the quadratic formula. And if you need a review of the quadratic formula, I will post a link up there to my video on quadratic formula. Okay, so we're going to do one of these per slide because some of them do require quite a bit of work. I just didn't want it to get crowded, so it's not like slides cost money. So this first one is very straightforward. The radical is already isolated, and so the first thing we would need to do here is undo the radical. But going into the thinking process that I talked about in the lesson, what we really are doing, and we want this to be intuitive. Okay, we don't even really want to think hard about it. We want this to be something that goes on in our heads. Whoops. There we go. And look at what's being done to the x there. So the first thing that's being done to the x is it's being multiplied by 3. So if you were to plug in a number right here, say you plug in a 1, and you were asked to evaluate it, what would you do first? Well, you would do 3 times 1. Okay, so you'd multiply by 3. Then you would subtract the 2. Then we subtract 2. And then after you subtract 2, then you would square root it. Why? Because the square root is going over the entire thing, including the minus 2. And so the third thing that we are doing is square rooting. Now, when we go to solve it, like if this is our order of operations, okay, when we go to solve it, we're going to back up. So the last thing that we did will be the first thing that we undo. And so how do I undo a square root? Well, I square something. How do I undo subtracting 2? I add 2. How do I undo multiplying by 3? I divide by 3. And so that is what outlines, like, what are we going to do to solve this? We're going to square both sides, and then we're going to add 2, then we're going to divide by 3. Okay, and here's what it looks like. So you might start by copying the problem over, and then I usually write this in a different color when I'm doing it to review, when I can just pull a different color. Okay, and we square the square root, and that gives us what is inside. It does not apply to the 3x or the negative 2, so we're not going to get a 9x squared. We're not going to get a 4. Nope, nope, nope. That squaring is just getting rid of that square root. And then we have on the right-hand side 10 squared, which is 100. And now we'll add the 2. So we get 3x is equal to 102, and then we divide by 3, and what is that? 34, which is what I thought it was. And if I just looked at my solutions that I did earlier, like 34. All right, and you can, if you want to, do a check on that. Checking is one of those things that sometimes it's important. So we have 3, and then we're checking out a 34 minus 2 is equal to 10. So we do 3 times 34, that is the 102. And then 102 minus 2 is 100, and the square root of 100 is 10, and 10 equals 10 is true. So we know we did it correctly. Yay. Moving on. Okay, so this is another one. This is one where you have to isolate the radical, and I'll kind of walk you through that thought process again. I know you're checking your work, but this is like really important. So the thought process. So what do we do? Get a pen. With our thinking. Having trouble writing. Okay, so what is happening to the x? Well, the first thing that's happening is we're adding 11. And so we start off by adding 11. Then we are taking the square root of that whole thing. So the next thing that happens is the square root. And then after we take the square root, now we're going to add 5. And I do want to point out, I know I pointed this out in the video, the reason that is adding 5 is because the 5 is positive. It is not because of the plus sign. The plus sign is telling you that the radical is positive. The fact that it is a positive 5 is why it is adding 5. And so we add 5. So that is my order of operations. When I go to solve it, we are going to reverse all of these. So we're going to subtract 5 instead of adding. We are going to square both sides instead of taking a square root. And then we're going to subtract 11. So that kind of gives me my game plan. So coming over here to the left, we're going to start by subtracting 5 from both sides. 5 minus 5 is 0, leaving me with x plus 11 under the square root. 9 minus 5 is 4. My next step will be to square both sides. And when I square a square root, I get what's inside. So that basically just gets rid of that square root, busts the x plus 11 out of square root jail. 4 squared is 16. And then my last step is to subtract 11. And so I am left with x is equal to 5. Yay. And of course, if you wanted to check that to see, like, would that actually work? Yes. All right, next one. So this is one that has a little asterisk on it. This one does require use of the quadratic formula and is messier to square. And so on this one, if you look at this one is not going to come out as nicely. And the reason why is if you would do that thinking part over here, we're going to have a problem. Why are we going to have a problem? Because we've got 2 x's. Okay, so on the left, I am multiplying by 4 and then adding 5 and then square rooting. So you say, okay, well then I'm going to subtract 5, divide by, no, I'm going to square it, subtract 5 and then divide by 4. But on the right hand side, all I'm doing to the x is adding a 1. And so there's no really great game plan there. The only thing I can say for sure is if I want to find out what x is, I got to get that x out from under the square root. So I guess we've got to square it, right? So I'm going to go grab my pen and we're going to square this. When we square the left-hand side, we are squaring the entire left-hand side. So I'm putting parentheses around the whole thing and saying, hey, square this whole thing. You cannot square things in chunks, okay? And so I must do the same thing with the right-hand side. I must square the whole thing. Now, if you're wondering why can't I square things in chunks? Okay, I'm going to give you an example over here. I'm going to say 2 plus 3 equals 5. Okay, and let's say I square the right-hand side, and so I get 25. And I try to do it on this side by squaring it in chunks. So 2 squared is 4, 3 squared is 9, and you can tell, no, that actually doesn't work. Okay, it actually doesn't work. So that's order of operations. One of them, you'd be adding them and then squaring it. The other is squaring and then adding, and that does make a difference. So why we've got to group them and square the whole thing as a unit has to do with those order of operations. Really, really important, and also a very, very common mistake for students to make. And it's not because they don't understand the operations and how the operations work. It goes back to the order of operations. On my left, I'll have 4x plus 5 because we're undoing the square root. On the right, though, this is x plus 1 times x plus 1. So if you want to, you can do that using foiling. You can use an area model. You might even be able to do it in your head. 1 times x is 1x. 1x, 1 times 1 is 1. So on the right-hand side, I've got x squared plus 2x plus 1. Now I have a quadratic, and this is where that quadratic skills come in, and you might look at this and say, okay, I've got square rooting, or not square rooting in this case, factoring or the quadratic formula. Those are your options for how to go about solving this. Either one of those require a 0. So we're going to start this off by getting the 0. And I'll do that by subtracting 4x from both sides. And I'm also going to subtract 5 from both sides. So on the left, 4x minus 4x is 0, 5 minus 5 is 0. And on the right, I'm going to have 2x minus 4x, which is negative 2x, and 1 minus 5, which is negative 4. Now, you might play around with that a little bit and say, do I think that is factorable? But it is not. There are not two factors of 4 that will give me a 2. Okay, I can get a 0, I can get a 4, I can get a 2. I think that's it. Not a 2, a 3. Sorry, a 3 out of it, but not the not a 2. So that means we've got to go use the quadratic formula. The quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. In this problem, my a value is 1, my b value is negative 2, and my c value is negative 4. So I go to plug this in, I will have the opposite of b. The opposite of negative 2 is positive 2, plus or minus the square root of negative 2 all squared minus 4 times 1 times negative 4 all over 2 times 1. Alrighty. Under that square root there, negative 2 times negative 2 is positive 4. Negative 4 times 1 times negative 4, well, negative 4 times 1 is negative 4, and negative 4 times negative 4 is positive 16. And 2 times 1 is 2. All right. X is equal to 2 plus or minus the square root of 20 over 2. And now we've got to go back to earlier in this unit or this body of knowledge, which is simplifying that square root of 20. And so I'll do a little bit of scratch work off to the side with that. If I were to get the prime factorization of 20, that would be 2 times 2 times 5. And it's a square root, so I'm going to look for a group of 2. And so it simplifies to 2 root 5. You could also get there from right here, saying that the square root of 4 is 2. And so we end up with this being 2 plus or minus 2 root 5 over 2. And then you might split that up, recognizing you got a bunch of 2's there. Okay. And those 2's cancel and cancel into 1's, leaving me with 1 plus or minus root 5. Now, this one would also solve fairly well using completing the square. Okay, but that is a less common strategy, so not as many people are going to have that come to mind. All right, and now if you were doing this one out and if you made it all the way to 1 plus or minus the square root of 5, give yourself extra gold stars today, yay. If you got lost somewhere along the way, did you get lost in the squaring of the binomial? Did you get lost in setting it equal to 0? Maybe you made a sign error and you said b was positive 2 instead of negative 2. Maybe you didn't know the quadratic formula, and so you do not have those numbers here plugged in where they like the right numbers in the right places. You've got positives where you need negatives and vice versa. Yes, it does matter. Maybe when you got here, you just changed the whole thing to a decimal. That's not necessarily wrong. The directions didn't say to leave it as a simplified radical, so I wouldn't call that wrong. Just you want to say like, could I do this with could I follow this as far as I was supposed to. Maybe you tripped up on simplifying the square root of 20, okay? Or maybe you got here and then didn't quite know what to do with all those 2's floating there. So it's important if you didn't get all the way to the end that you take time to look at where in this problem did I have the wrong thing written down. Right, this next one is a simpler one. This is a cube root, and so we would undo the cube root by cubing. And this one, because you're not dealing with multiple x's, you can come up with that like thinking plan. Okay, that works out okay. And you think, okay, what's happening? What exactly is happening to my x here? And so we can make our little plan. First, we're multiplying it by 2, then we are adding 5, and then we are cube rooting it, okay? And so my solution is going to reverse that. So we're going to start by cubing it, then we're going to subtract 5, and then we're going to divide by 2. So there's our game plan. Taking a look at this, if I cube what is on the left, I must also cube what is on the right. Cubing a cube root is going to leave us with whatever was inside, so 2x plus 5. 3 to the third power is 27. Be careful there. A common mistake is to say 9. Okay, it's just to see the 3's and be like, there we go. But that's 3 times 3 times 3. Now we will subtract the 5. And we get 2x is equal to 22, and then divide both sides by 2, and we get x is equal to 11. Yay. Okay, next one. So next one, I think this one is, I don't think this is a huge deal here. We got to do a little bit isolating. So we got our thinking, and we ask ourselves what's happening to our x value. So we are subtracting 1 on our x value there. So we are subtracting 1, then we're square rooting, and then we're taking that whole thing and we're multiplying it by 4. So how do we undo it? Well, we're going to start by dividing by 4, and then we're going to square it, and then we will add 1. I don't know why I wrote the word add there. No idea. All right, so let's start by dividing by 4. So 4 divided by 4 is 1, and that is going to successfully isolate the radical. 20 divided by 4 is 5. Now we'll get rid of that square root by squaring both sides. So we will have x minus 1 is equal to 25, and then adding 1 to both sides gives us x is equal to 26. All right. Second half of the problem set. This problem set is going to be a lot longer than the initial lesson. All right, so what do we have going on here? Let's do some thinking. Okay, and we go find our x, and we ask ourselves, what is being done to that x? So first thing I see being done to the x is it is being multiplied by 2. Then we are adding 9. Then we are square rooting it. And then we are subtracting 3. So my solution will be add 3. Then we'll square it. Then we will subtract 9. And then we will divide by 2. So you're just doing that, basically unweaving all of that. And now that we've got our game plan, let's go ahead and do it. We will add 3 to both sides. That effectively isolates our radical. Negative 3 plus 3 is 0. 2 plus 3 is 5. And then we square both sides. That will get rid of the square root. So we get 2x plus 9 is equal to 25. Next step is to subtract 9. So that gives me 2x is equal to 16. And then divide by 2. X is equal to 8. Yay. Now, what's kind of cool to look at is if you do the check, you basically can see all of those numbers come back. Okay, which I think is kind of neat. All right, so when you go to check it, you plug in the 8, and then 2 times 8 is 16. And so like you can see there's my 16. And then you would do 16 plus 9, and there's the 25. And then the square root of 25 is 5. Okay, there's the 5. And then 5 minus 3 is 2, which like just weaves you back to the beginning. So I think that's kind of neat just to watch that. It really gives you a better foundation in what's happening when you're doing the solution. Like, why do these steps make sense? You're just weaving the thought process in the other direction. Okay, I think the thing that might trip you up on this one is the fact that you're subtracting the x, okay? So we'll go ahead and square both sides. So squaring the square root gives us 5 minus x. 1 squared is 1. And what, again, might trip you up is the fact that you are subtracting the x. What that means is that the x is negative. This 5 right here, that 5 is a positive 5. So if I want to get rid of that 5, I have to subtract it. Okay, because it is positive. So 5 minus 5 is 0. That negative right there, that's still there. Okay, when 1 minus 5 is negative 4. We didn't actually do anything with that negative, okay? It's still there because the x was negative. Now, of course, we're not looking for negative x. So when my students see this, I will sometimes approach it by just like a verbal way of saying it. I'll say, well, if negative x equals negative 4, then positive x would be, and usually students say positive 4. Why, yes, it would, because that sort of thing makes sense. Now, if you're not sure about it, you could do this. You could simply divide both sides by -1, and a negative divided by a negative would give you the positive, and then you can see it done out operationally. But that intuitive, if negative x is -4, therefore positive x would be positive 4. That is actually sound reasoning there. Okay, now we go back to stuff that's not a square root, okay? This is a fourth root, but we don't overthink it. A fourth root, if you want to undo it, you will raise it to the fourth power. And you won't see those too common, too often. They're not very common. Fourth root raised to the fourth power undoes that radical and busts that out of jail. 2 to the fourth power is 16, and then we would subtract 3. The reason you won't see that too often is because the number that you're raising to the fourth power is going to get very big very fast. So you've got to keep that number, whatever number you're going to raise to a higher power, you've got to keep it fairly small, because as soon as you get up into like the number 4, the number 5, you're going to be way up into the triple digits, and usually we don't want problems, numbers that big in these problems. Okay, almost done. So this is another one where we do have to square both sides, and we've got to square the binomial. So if I want to undo this, I've got to square it. And then we got to do the same thing on the other side, but we've got to do it as that unit, as that group. This is another one where you can't really formulate a game plan because you have different things happening to the different x's. You've got more than one x, and it's not this one thing that's happening to it. On the left, that is going to be, again, squaring that binomial. So a nice review of our quadratics here. The square root squared gives me the 8x plus 1. And then you might want to do some scratch work over here. So 2x times 2x is 4x squared minus 2x plus 1. So this would be 4x squared minus 4x plus 1. And now we've got a quadratic. So we're either going to factor this or we are going to use the quadratic formula. Both of those require that we get a 0 on one side of the equal sign. And to move in that direction, I'm going to go ahead and subtract 8x from both sides and also subtract a 1 from both sides. So we get 4x squared, negative 4x minus 8x is negative 12x. Now this is interesting. 1 minus 1 is 0. And of course, 8x minus 8x and 1 minus 1 is 0. So I have the 0 on the right-hand side. So this actually spares me from having to do really messy factoring. At this point, we would look for a GCF. Okay, you could engage the quadratic formula here, but you probably don't want to. So we would look for a GCF. Now, if you want a quick review of how do I find that GCF? Okay, so we're looking for what is the GCF between 4x squared and 12x? Well, 4 factors into 2 times 2, and x squared is x times x. The 12 would factor into 4 times 3 times x, and then the 4 would factor again. And you look for what do those have in common? Well, I see they have a 2 in common, and then they have another 2 in common, and they also have an x in common. So the GCF would be 2 times 2 times x, or 4x. So the 4x would come out. And then you'd look to see what was left over. Well, I have an x and I have a 3. And of course, the minus sign is still there. So now we would use the zero product property, which says if I have multiple things multiplied together, or more than one thing multiplied together, and the product is 0, then at least one of those factors had to be 0. Now you could say the 4 is equal to 0, but of course we know that 4 is not equal to 0, so don't bother. You could also say this: the 4x is equal to 0, or the x minus 3. Here you could divide both sides by 4, and so x could be 0. Here you would add 3 and get x is equal to 3. Now, when you get more than one answer, it is usually pretty wise to check those answers, because this is when you can get into this thing called an extraneous root or solution. And so let's go ahead and check those. So if I have 2 times 0 minus 1, is that the same as the square root of x times 0 plus 1? 2 times 0 minus 1 is -1. And that one does not check. I get and I did not want a problem that would do that. And now I'm going to double check my thing here. That does not check. And so we've got an answer dumped out in here that does not actually check. And the reason it doesn't check is because you assume it's a positive root when you take the square root of 1. And so that does not check. Now, what I can't do in the middle of this video is like kind of go over and look at a graph. Oh, wait, I can, but I can't show it to you. So I can graph it on my phone. Let me go ahead and pause the video. No, I can't pause the video because last time I tried to do that, it did not let me resume recording, or it did, but it messed it up. So we are going to check this out to x minus 1 and get the line, and then we want the square root. Y equals the square root of 8x plus 1. And yep, we are good to go. That is an extraneous root. Well, that was an accident. That was not supposed to happen. So I'll put a note in the description box regarding that, because that was not supposed to happen, but it did. Oops. Let's go ahead and check the other one. So if we have 2 times 3 minus 1, and we want to know if that's equal to 8 times 3 plus 1 square rooted. So this is 6 minus 1. This would be 24 plus 1. 6 minus 1 is 5. 24 plus 1 is 25. And the square root of 25 is 5. And so what we do is we cross that out and we say only the x is equal to 3 is the solution. So that was not supposed to happen. That is my fault. So my apologies. If you would like to criticize me in the comments, don't be too cruel. Okay, so we get those answers there. All right, let's move on to the next one. All right, last one, because this video is getting really long. So this one has a little asterisk. This is also one that requires the use of the quadratic formula. And so we're going to start off by undoing that square root by squaring both sides. And again, we want to remember to square everything on both sides. So on the left, I get 6x plus 12. On the right, that's 2x times 2x, or 4x squared. And I get a quadratic on this one. So I need to get the 0 on one side. So we're going to go ahead and subtract the 6x and subtract the 12. 6x minus 6x, and 12 minus 12 gives me the 0. And I land here. Now, here, the first thing I noticed was 4, 6, and 12 are all even numbers. And so I can factor out a 2. And that shrinks things. Now, You can also do this at this point. I would normally just drop it out, but I divide both sides by 2. And what that basically does is it shrinks that whole problem down. And so you might be like, well, wait a minute, is that really the same problem? Yes, in terms of the solutions, yes. Okay, in terms of the solutions. Now, you could think about this and try to factor it, but it turns out that this is not factorable. So we've got to kick over to our quadratic formula. A is equal to 2, B is equal to -3, and C is equal to -6. Here's my formula. The opposite of B plus or minus the square root of B squared minus 4AC all over 2A. The opposite of -3 is +3. And then we'll have -3 squared minus 4 times 2 times -6 all over 2 times 2. X is equal to 3 plus or minus. All right, -3 times -3 is +9. And here we've got a bit of a mess. So -4 times 2 is -8, and -8 times -6 is +38. All over 2 times 2, which is 4. And then 3 plus or minus, this will be the square root of 57. And now you might have to think, okay, like, can I simplify the square root of 57? So 57 is, what is 57? That is 3 times 19. Okay, which, yep, that doesn't simplify. And so that is the end of the road on that problem. So a little bit messy there. It's kind of messy. So there you go. One major snafu with that, and a fairly lengthy video. This video is like 100% longer almost than the actual lesson, but hopefully you got some good practice. And if you're looking for ones that, well, I was gonna say ones that have extraneous solutions, but we saw that accidentally in this video, but problems that involve more than one square root, then you want to check out Radical Equations Part 2, and I hope to see you in a future video.